Yeah, so our next presenter is Deepak. You've heard from him before, so he doesn't need another introduction. So take it away, Deepak.
I'll be trying to make it 5:30, which is my supposed to be finish time. So basically why I'm here is I'm supposed to give a presentation on Cryptodev APIs. How many people know about Cryptodev? Or are they using it or in any form or shape or, okay, some people. So what I'll start is basically, okay, so we have, so like what I put together just a slide of introduction about Cryptodev, how it started, what it's doing, what are the features there, how we integrated like Cryptodev into VPP framework, something about like comparing the like performance between the different PMDs, future work, and like summary. So stop me whenever you find something interesting, or if you find any like question in your mind, just stop me there and I'll be able to answer this. So starting with the Cryptodev introduction. So this is how the Cryptodev looks like as of now. Just to focus on, as of now, like till today, it's only focused for symmetric crypto workloads. There's no support as of now for asymmetric. If people are watching the mailing list, there's already an RFC on adding a support for asymmetric. But as of now, in DPDK 1705, there'll be only symmetric crypto workload support. What DPDK Cryptodev consists of? It basically consists of the pole mode driver. It's based along the lines of the eThread driver, how we have. So we have the PMDs, we have the acceleration through hardware and all this thing. It provides a standard API across all the PMDs. So these are the PMDs lower down, QAT PMDs, ASNI PMDs. On the right, we have Ssl Scheduler PMDs and ARM V8 PMDs. So these are standard. So we have the API so that we can use all the PMD in a standard way. So you don't have to create another set of APIs to use any other PMD. And what it does is basically it provides us an effortless migration between different PMDs or like different use cases. I'll be explaining a bit more on in some of the slides, but this is how basically a Cryptodev looks like. We have various components. You can check on the API of this about like device management APIs and all this thing, and then we have the PMD layers, which are for quick assist, maybe for Intel high performance libraries. We have OpenSL one. We have the scheduler PMDs now with extensive support now. Just a snapshot of what, as of now, PMDs looks like. So we have on the left quick assist PMD, which is a hardware acceleration support. We have ASNI multi-buffer GCM, ARM V8 support for optimized software acceleration libraries. Then we have catered most of the wireless acceleration libraries, so Snow 3G, Kasumi, and Zook, so which satisfies all the wireless use cases. We have OpenSL for non-optimized software implementation. A scheduler, I'll be focusing a bit more. I have a special slide on this, a scheduler, to give more input on this, basically how you can manage different accelerators on this. And then we have a null, which is for that test purpose, especially from the IPsec perspective. So in terms of algorithms, for 1705, I can say these are the algorithms which are supported now. We have block cipher algorithms. Most of them are AES, CBC, counter mode, which is 128, 192, 256 bit. We have all the wireless algorithms like Snow 3G, Kasumi, Zook. We have the AES CFP, which is more like a DOCSIS algorithm support needed. So we have added that support in 1705 timeframe. In terms of hash, we have MD5 and all the HMAX, SHAs, and again the wireless ones. In terms of AEAD algorithms, we have the GCM implementation in place. So 128, 192, which is only available as of now on the ASNI and not on the hardware, and then 256 bit. So these are the algorithms which are there in 1705 or will be there in 1705 timeframe. Pardon me? Yeah, so which one you are interested in? Yeah, in general, most of them. So if you see the star, so MD5 HMAC as of now, it's only have the QAT implementation. And the other one which only have software is 192 ACM support. Perfect, thank you.
Can you repeat the question?
Oh, so what the gentleman was asking was that, like, whether do we have all the software support of all the mentioned algorithms? So except the MD5 HMAC, which is only available in the QAT implementation, all others have implementation, either in the form of OpenSL PMD or through the Intel high performance libraries. So moving on, this is a simpler snapshot from the morning when we talk about the life of an FE packet. This is more about specifically focusing on the Cryptodev part, how the packet will flow. So if you like follow the red one, the like red flow, it's all about how a plain text like comes. It goes through each dev PMD, goes to the application code. Application like can decide in terms of which PMD it want to use, whether it want to use the software crypto PMD or a quick assist PMD or any other PMD. It goes through like Cryptodev API. If you're using a QAT PMD, then it will go through a hardware accelerator and back, and then it will like follow the same path from where it came. So just to like give a smaller, cleaner overview of a packet flow in terms of Cryptodev packet processing. As I told about the effortless migration, so we have L2 forward test application in DPDK, and these are some of the parameters which we use to test applications. So in this specific example, we are using a alt chaining for like Cipher hash. It's AES like CBC with HMAC. So I specifically marked -W84 84.00. So this is the device ID for quick assist. If I need to use the software implementation through ASNI PMD, you just need to change the VDEV. So basically what you're doing is you're defining the device name, and that's all you have to change. All other parameters remain same, so you don't have to like worry about the parameters, other parameters, or is there any special parameters for QAT or a special parameter for ASNI. So just define the device name, and then it will auto like configure which like PMD to use. So this is the same thing. So now we are on scheduler PMD. So we started on 1702. We added a scheduler PMD. So basically what a scheduler PMD is doing is it's managing or distributing the like crypto ops to various different like crypto PMDs. So basically on the lower down you see on the three like Cryptodev. So they're basically the three Cryptodev PMDs. So what it does is manages the workload. So it supports various distribution mode. In 1702 we added a round robin mode, which is more like balancing the workload across the multiple accelerators or like multiple crypto PMDs. In 1705 RC1, the packet size based mode was integrated. It will be there in 1705 unless there's anything happens. So, but we are pretty much confident that like packet size scheduler will be added to 1705. In the morning, I talk about the future roadmap. In 1708, we are planning to have a multi-core scheduler PMD, which will be utilizing a pool of cores across the available cores, and it will try to maximize the usage of all the cores, as well as along with if you have a QAT like device in there, it will try to use that. So basically, these modes are trying to enhance and make out the best of available resources. Yeah. Oh my God. Sorry, are you okay?
So the scheduler PMD, based on the crypto operation supported, will it automatically schedule or select the appropriate PMDs?
Yeah, it will. So we have a policy of hardware first. So based on if you're doing the packet size, generally in almost all the hardware accelerators, the like bigger the packet size, it more like favors the hardware acceleration. So it will on the like packet size, it will see if the like packet size is bigger than X amount, it will throw it to like hardware PMD. But you need to define. That's one of the slide I have is you need to like define which crypto PMD you want to use. So if you don't have a hardware accelerator with you, then you will not obviously you will not be able to use it. So then the scheduler PMD will look into your config file and see, okay, which are the ones which you want to use, and assign the ops to those.
I have another question. So let's say I have a OpenSSL engine.
Yeah.
I have a PCI device for which I have a OpenSSL engine. Should I write a crypto PMD, or the OpenSSL PMD will work directly with the crypto device through the engine.
Like repeat it for me, sorry, I didn't get.
So the OpenSSL, right, it supports something called as engine. So
Yeah,
if you
it's
have
in the latest OpenSSL version, right? So
It's
this
not-
like engine concept is not very old. It's new for the OpenSSL 1.1.0.
It's an old concept.
Okay.
So whenever you have a device, you can write a OpenSSL engine,
Okay.
and then mention that use the engine instead of using a software implementation.
Okay.
So if I write a engine, if the engine is already available for my device,
Okay.
can I use the OpenSSL crypto driver to access my engine?
Yeah, then you have to modify the OpenSSL PMD, right? You have to link your engine to the OpenSSL PMD.
Yeah.
Yeah.
So-
So if you link your OpenSSL PMD with your engine, then in the config file you can specify that you want to use the OpenSSL PMD, and then it will automatically configure for you. But then you have to like set the rules of your PMD. So yeah. Yeah, no problem. So the other thing which it like provides the API to manage slave, set modes, and enable disable ordering. It also provides the API for user to use his own crafted mode. What I mean to say here is that if you want to have your own mode, except like you don't want to use round robin, you don't want to use packet size space, and you don't want to use like multi-core. You can still create your own mode, but you don't have to start from scratch. We are providing APIs for detach, attach. We are doing start, stop, and all these things. So you can use those existing functionality at the base, and then create your own mode, and if like possible, upstream those modes so that we can also use it. So before me, Shweta gave a like fantastic overview of the VPP and how VPP is working and all these things. So I'll not spend a huge amount of time. This is well known. Like it's an open source Linux Foundation project. It's highly performing like GitHub plain platform. It's a packet. So like VPP is one of the like component or umbrella project under FIDO, which is a like packet processing engine using DPDK as network IO. And its run to like completion mode is the one which makes it attractive. So these are the nodes which might be different. I'm not a big fan of like circular things, but these are things, yeah. So how we integrated the DPDK Cryptodev into the VPP IPsec engine is basically, this is the like figure how it looks like. So it's on the same lines as how each dev was integrated. So VPP IPsec or FIDO already supports IPv4, IPv6, IPsec, ESP tunnel transport mode, and same management. So like Cryptodev was not integrated. What we did is we added the DPDK Cryptodev there to provide support for Intel high performance libraries as well as the Intel Quick Assist implementation, which is already present in like DPDK Cryptodev. As in the previous presentation from Shweta, right? She said like, okay, you can add few nodes in there, and then so we added basically 3 nodes, which is like DPDK crypto input mode. You can see in the middle the red one. So the red ones are the ones which we replaced or we are adding new. So it's like, so it was easy enough to add those ones because of how VPP is organized. So that's how we are adding those 3 nodes, and you can enable just a like configuration. You have to use VPP, use DPDK Cryptodev as yes, and then it will use like DPDK based like Cryptodev. So there's no other special IPsec like configuration which is required as of now. You have to allocate enough crypto resources on the best effort approach. So that's what I was saying, that we follow like first hardware and then software. If there's no enough crypto resources which are not assigned properly, then it will like drop all the packets. So user only need to provide like Cryptodev which are available in the startup like config file. So it will see what are the available resources available to it, and then it will use those. Moving on to the performance. What I'm showing in the next slide is a comparison between the 2 PMDs. It's not absolute numbers. It's more like a graphical representation of how things vary with packet size. So on the x-axis we have like packet size starting from 64 bytes going all the way to 1420 bytes packet size. So this is to show that we are using AES 128 CBC HMAC SHA-1, and if you use the Intel Quick Assist, which is being all blue, but the dark blue one is the Quick Assist, the top one obviously, and the lower one is the ASNI multi-buffer. So like this is to show that if you are using a smaller packet size, 64 byte, probably use multi-buffer and you will be happy enough. But if you're increasing, if the use case is about more than 512 packet size, then like prefer using like quick assist. And for the scheduler PMD, if you're using a scheduler PMD, you can use both at the same time based on packet size, and you'll be grand. Like some of the future work, this is more like a roadmap, but it's not like final thing. It's like evolving, and there's a start there that it might change anytime without noticing. So in terms of, we have 4 main buckets of things which we plan to use or plan to do in future. In terms of like performance, there are always cleanups and performance optimizations, which they're always there in terms of QAT PMD as well as software PMDs and refactoring of the code, adding new stuff in there. In terms of algorithm support in QAT PMD, there are a few things about like DES, Zook, and the like DOCSIS specific algorithms. So Zook and DOCSIS specific algorithms are already integrated into 1705 RC2. In terms of software PMD, again, the like DES and the software implementation through Intel high performance libraries is for like DOCSIS. In terms of scheduler, as I already said, packet size based ordering and multi-core scheduler is on the map. In 1708, we are already working on multi-core scheduling mode. And then the VPP integration, what's in there is more like performance optimization, enable DPDK Cryptodev in VPP, IKEY, V2 mode, and enable DPDK Cryptodev scheduler PMD. So these are mainly the 4 buckets of things we are planning to do. It's not final thing that we'll do it.
This is regarding the MACsec. If my Ethernet polling mode driver does not support MACsec, is there any plans to use the Cryptodev for doing the MACsec transparently?
I'm not aware of. Maybe other folks. Helen, if there any support needed? I know there's a MACsec support added already, I think in 1705 or 1702, but I'm not sure whether. 2, yeah. It's already there in 1702, right? Yeah. Okay. Yeah, so this is how we plan to use. I know we are also, there's RFC on asymmetric crypto, thanks to like KVM folks for bringing it together. So it really looks interesting, and we're looking forward to it. So the roadmap might change a bit, and we'll see how we like support the asymmetric like crypto. So in terms of like summary, it provides as of now symmetric crypto algorithm support. Future might be asymmetric as well, but we'll see how it goes along. It provides both software as well as hardware implementation. So this is only from the Intel side of house. In terms of software, I'm talking about OpenSL as well as Intel high performance libraries. If you see the features, we have still some work to do, and when asymmetric is like coming up, there's a lot of work involved in that. So there'll be a good amount of work in there. And as I showed in the graph, right, that based on packet size and like what's the use case, hardware provides generally major boost in like performance over like software implementation. That's all I have, folks. Any questions?
One question.
Yeah.
Yeah. Cryptodev supports any type of payload or only specific to the IPsec technology. And in IPsec, is it supporting only the transport or the processing as well?
I know it supports only IPsec workloads as of now. It's mainly for the IPsec, so like basically.
In tunneling mode or only at the transport mode?
That I need to check, and like I can like come back to you on this. I'll think of
Is
it.
there any roadmap for supporting TLS or SSL cables?
So are you talking about the now asymmetric way, right?
No, at the layer 4. So SSL is secure socket layer and TLS
No, as
is
of now,
transport
there's
layer.
nothing on the map.
Deepak, thank you, and it was a good session. Just on the MACsec, on this side where Wipro board is there, though I'm not from Wipro, I'm from Aruba Hewlett Packard Enterprise. So MACsec, we always found it's interesting on platform wise. So it's good if we can have one more session or anything like that, at least tomorrow in the demo session, if we can hear something more on the MACsec.
Okay.
Yeah, thanks.
Yeah. Like thanks for the session. Anything else? One? Or you are just ready to go to classes? Okay. Thanks, folks, and like thanks everyone for like coming to DPDK Summit. Okay.